how we are going to understand in detail about all FWD and RWD, 4WD, AWD. So what it means, so the FWD is the forward wheels where the front wheel get the suspension, and RW is the one, it is a rear wheel, it will get the suspension more, and 4WD is the one which will get uh, the wheel individually, the suspensions, and AWD it will get all wheels at a time. So it's depends, like we understand about in detail about this, how this drive system will works. So vehicle drive generally refers how it is configured for the vehicle drivetrain. So and how the power is distributing from the engine or the motor to the wheels. So that is a drive measure. The point of the vehicle drive type is how that power is delivered to the wheels. So here are in detail, like we are going to discuss about a forward wheel drive and rear wheel drive and all wheel drive and four wheel drive and electric vehicle drive type and specialized drive types. So like all the vehicles, sometimes we used to see 4x4 means the four wheel drive. 4WD is the, this is also same 4x4, and some vehicles you able to see it for EFWD, and sometimes you will see it as a 2 cross 4 means like the front wheels can have the access. So we should understand how this drive system will work for the engine or motor to deliver the wheels. And the next will be a part of a forward wheel drive. So mainly as we know, the front wheel will take the responsibility for the propulsion and the steering. So the steering will be there, and the propulsion system is happened. Means propulsion system, it talks about the how we are driving uh, the wheel. So the wheel of the front wheels. So with help of the steering, we know that we are able to control, but the engine and transmission are mounted at the front. That is the lighted drivetrain component. So advantages of this is the better transaction on the slippery surface due to the engine weight over the drive wheels. Means you have the engine at front and wheels also have the front, and weight will be added more. So it gives some stability and when you are driving it. And fuel efficiency will be due to the lower weight and simpler design and more interior spaces on the driveline layout is compatible, because the more weight will be added in the front and back side you don't have much weight. So the disadvantage is that it is a limited handling performance compared to the other systems. So the torque steer, like pulling to the one side under the heavy acceleration. And common applications of these front wheel drives are the small cars and sedan and economic village vehicles. And next will be a part of a rear wheel drive. So rear will be like we are driving, giving the power or drive the power to the rear wheels. So the majorly these drivetrains usually runs from the front engine to the rear axles. So that commonly in the vehicles are longitudinally mounted on the engines. It is better for handling and balance the weight distribution for the front and rear conditions. And the poor, it have the disadvantage. It is a poor transaction on the slippery or icy roads. We cannot use for the icy roads or slippery conditions, and heavier and less fuel efficiency compared to the FWD. And common applications: sports car, luxury sedan, and pickup trucks. So the rear wheel drive will be, and all wheel drive. So mostly the power will be distributed to the all four wheels as needed. It will maintain the optimal traction. Traction is the one factor where it will maintain on the road, and usually it includes the central differential and economical system to manage the power distribution. And automatically, based upon the road conditions, it will be adjusted, and where we can enhance the traction and stabilize the various conditions, including rain or snow, off-road surfaces. It will be easy for driving. So, and next, it is no drain intervention is required, and sometimes the disadvantage is the weight will be more, and it is a complexity because to deliver the power to the all wheels. and fuel efficiency also it will be increased, because the four wheels we need to supply the fuel um, propulsion. The fuel efficiency is more and more will be added. That is the one disadvantage. And commonly, like crossover SUVs and some other performance cars will be comes under a part of all wheels. And next will be part of the four-wheeler drives, like it will transmit the power for all the wheels, and typically some situations where we can switch the two-wheeler and four-wheeler, depends. Like if you need a two-wheeler, we can switch the front or we can switch the rear. So however we need. This is a one good feature we can say. And usually it includes the transmission of the manual control of the proper power distribution. So it's specifically designed for the off-road conditions, the 4WD. So the Jeeps or the Wranglers or some of the Mahindras, Thar. So it will be a part of a 4D. So it means it will be a part of where the power will be distributed and specifically designed for the off-road conditions. And it is superior for the off-road capability, and traction will be, and it can be handled extremely good during the driving on the mud or sand or rocky. And disadvantage will be the heavier and more expensive than AWD, and requires driver expertise to operate the efficiency, because when we are running on the mud or sand and rocky conditions, so it will be uh, difficult to the driver should handle uh, clearly. And the common applications is off-road vehicles, as with the pickup trucks and SUVs. So it will be a part of this. And next will be part of the electrical vehicle drive types. So electric vehicles can specifically drive in the configuration due to their specific reliance on the electric vehicle motors. So the front wheel drive type, it have the EV, where single motor it will drive, because as we know that previously we have talks about the engine and the propulsion system, and how that is giving to the rear wheel or the front wheel. Now coming to the electric vehicle, we have a motor, and how this motor will be placed and towards the wheel rotation, or the front or the back. So all the it is a having the single motor driver that the front wheels makes to rotate, or it is a common in small electric vehicles for any city driving. And rear wheel drivers EVs, singular motor that drives the rear wheel. So the front, it will drive the front wheel. The single motor, it drives the rear wheel. And it provides a better handling and sporty feel, I can say. All-wheel drive for EV, it have a specifically dual and multiple motors. So usually it will run both dual or four. So, but it requires the superior performance, and you will get a good traction for all the wheels, because it is a EV where the power will be distributed commonly across the wheels, where it will drive on self or independent towards the other wheels. So all wheels drive is one formulated features for the EV vehicles. And there are specialized drive wheels like 4 we have a 6x6 and 8x6 drives. So power will be distributed to the 6 or 8 wheels, as we discussed earlier. Commonly, it is used in the military and heavy duty and off-road vehicles. So the driver differential drive, it is used in a specific conditions, like the robotics way, where it able to operate and employ the independent power to the each wheel, because every every hardware it is combined with the motor, and motor will deliver the sufficient power to the wheels to move in different directions and make the direction to be similar. And what are the major factors it requires? So for each and every motor, it requires the inverter and the battery. So from the battery, the power will be supplied to the motor. That is how, like 6x6 or 8x6 would require the sufficient energies or the power to be delivered to the motor in different conditions. And how the automotive car models and ECUs are configured in the cars. Generally, it have the engine ECU, like the transmission ECU, means this is a controllers, battery management system, hybrid control ECU, and AVAS controller, and air conditioning ECU, hydrogen leak monitoring control, body integrated control ECU, ECU for cooling ID, uh, and headlamp ECU, junction box, relay box, CT ECU, seat heat control, driver side switch pack ECU, and power window ECU, and smart entry system, other comfort control, airbag ECU, and suspension, electric suspension control, parental control, parking brake control, electronical control 4D system, EPS, ESC ECU, AD ECU, DC-DC converter ECU, inverter ECU, onboard charger ECU, HUD ECU, car audio or display ECU, navigator control ECU, TCU, and meter. Means these are the some examples. Initially, generally, the vehicles are adding more. Adding more and more ECUs, the features and the functionalities of the ECUs will be varied. And moreover, the weight of the car is increased drastically when the functionality is added or the ECUs added. So, and for different features, the different ECUs will work independently. And coming to the driving, during the driving system, the vehicle will act according to the passenger need and the driver conditions. And that are some part of automation or drivings which makes the passenger to drive reach the destination smoothly. So that are the autonomous, and for supporting of the autonomous, the passenger side, the driver needs some attention on the road to make the passenger reach to the destinations. And for to make understand of different ECUs, how it will be configured and how the modules will be splitted. So initially the powertrain control module. The powertrain control module is the one where the power will be distributed and how it will be controlled with respect to the IC engines. So integrate IC engines here, the petrol or the diesel. So how efficiency it will be maintained, how the functionality will be worked, and how the operation is happening. Operation here is the fuel injection or the ignition timing or emission control. So other related functions, how it will be managing, that will be a part of a powertrain control models. And the infotainment system model or the instrument cluster model, ISM or ICS, we say that the driver seat position, where the driver can monitor the speed and other features, other functionalities that is happening inside the car, and where he will be able to see the display, and he will see the vehicle gauges and warning lights and the driver information about the system. And some part of the autonomous driving needed is the ADAS model or the ADAS ECUs generally will play major role. So that is ADAS means advanced driver assist system, where driver needs some attention when they're driving the way driving on the road. So to control these various safety and driving assistant features, the some of the functionalities is needed for the vehicle, like adaptive cruise control, lane keeping assist, and collision avoidance, and automatic car parking. So these are some features should be integrated and added to the car. And body and chassis control model. The bodies and chassis control is specific to the lightening of interior and exterior features, and the door locking system or the windows and seat control. There are some features. For some features, the ECUs will have separate, and moreover, to make the complete vehicle stable and to work on the to sustainable comfort to the passengers and drivers. So we need some functionalities to be added more. And towards the safety, the stability control and traction control and anti-locking braking system, ABS. So this will be a part of an anti-body and chassis control model, and where it will maintain a good suspension and It includes during the braking or any other conditions, the suspension will be playing major role for the comfort driving. And moreover, it regulates the vehicle heating and ventilation, so and air conditioning HVAC. It includes the temperature, how the airflow is happening in and out, and in during the ice or the fog conditions, the raining condition. So how the vehicle is maintaining the temperature. So it will be a part of the HVAC condition. And gateway module. So gateway module is the one the communication between the one controller and other controllers, how it is interacting with each other, and how it is communicating, how if any software needs to be updated in the recent purchased vehicles, so how the software will be updated. So via the gateway. So gateway is the one is the enter ECU, the initial enter issue. From the gateway enter issue, the other ECUs are connected and configured accordingly that the software related to the futures, it will be updated with the latest software automatically during the driving or the parking conditions. So the softwares will be make a major role for updating every time. So it's improves the safety and security of the features which available in the vehicle. So that's how the automotive cars and the models domains it will be data. So the propulsion train or the infotainment or the ADAS and the bodies and chassis and gateway modules. So these are the five different models and the domains most work on the automotive. What are the engine vehicles? So generally the engine vehicles, it was um, categorized as the internal combustion engine, ICE. So where it have the gasoline engine, diesel engine, and the gasoline it is mostly commonly used in passenger cars and gasoline engine. So that will spark the ignition as a combustion. It is a mixture of the fuel and air. And diesel injection is it will be found in the trucks and buses and some passenger cars. So diesel engine it will compress the air to the higher temperature and it will ignite the diesel fuel without a spark plug. So these are the major difference between the gasoline and diesel engine. And we have electric motor. Electric motor is usually runs with the battery. So the battery is it should be always rechargeable batteries. So when once the charging completes, the recharging of the battery, then again it should happen recharge again, the motor should rotate. It's a part of a recycling should be happening. And the hybrid electric vehicle HEV, it is a combination of the electric internal combustion engine with the motor and the gasoline or the other electric and propulsion. Plug-in hybrid electric vehicle, it is similar to the HEVs, but it will be built with the larger batteries. It will be recharged from the external power supply, mostly allows the electric only for driving ranges, and it have limited features. The plug-in alternative fuel cells are like hydrogen fuel cells and the natural gas engines. So with the help of these gases, the vehicles are driving as we discussed. And moreover, rotatory engines, it is also known as the Wankel engines. So rotary engines use the rotating the triangle rotor to the generated power, offering the high power to the weight ratio and a smooth operation. And turbine engines mainly found in some of the experimental and suspension vehicles. Turbine engines usually turbine the drive and compress to generate the thrust and machine power. And steam engine, it is a very old and initial page where the engine is started as a older type of engine rarely used in the modern vehicles. But steam engines generate a power by while boiling water or some. It will produce the steam when drives the piston or turbines. So each engine type has its own advantages and disadvantages in terms of inefficiency or power output or and the emission and sustainability of different applications. So advanced technology continues to deliver the innovation in the engine design with growth and more electrification on the alternative fuels, how to reduce the uh, pollution and natural impacting chemicals that is coming from the vehicle. So that the environmental impact is more and more, and how we are improving the efficiency. So that will be a challenging part. How does all this electrical engine vehicle works and electrical vehicle works? So we'll focus mostly on how all engine vehicle works. So first is the power. So every vehicle needs the power supply. So the power we are getting from the IC, the gasoline, or part of any diesel. So that will be combusted first. Then it will the fuel. It will be available in the cylinder, so in the IC. So it will be having the piston will move and up and down, and within the cylinder, the power will be generated. Once the power will be generated, like we have a different spark plug and spark ignition. So whenever the power is generated, the power will be transferred. The whatever the piston it is there, so it will be converted rotation motion by the crankshaft, and crankshaft is connected to the transmission, which will transfer power to the wheels through the series of gears and wheel movement. So as we know, like once the power is started, the power is started from the generation, so the wheel will start rotating based upon the based upon the acceleration we are giving. Once the acceleration, if you give more, the more power will be generated, and the more power it will generate, the more speed will be happened. And the power is transmitted from transmission to the drivers, like whether front, rear, or all wheel drives. That is a different axles or the drive shafts. And steering and control, because yeah, as the power is started and we know power is transferred and wheels also started. Now you need to control your vehicle. So for that, we need the steering and control. So the driver controls the direction of the vehicle, and while with the help of the steering wheel, so which is connected to the steering system. That steering system, it will transmit the driver input to the wheels. So accordingly, the movement he needed, and braking, because as the vehicle is started, and as we know, power is switched better and steering is under control. And now you need to stop or start the vehicle. So brake is the one, it essentially it will give the safety. So to control the high speed or low speed conditions, we need a hydraulic pressure. So the small apply of small force on the brake, you need to completely stop your vehicle. So it's possible with the help of the hydraulic pressure that will be formed, created during the braking. So the pressure, it will activate the brake, and the calipers at the drums types will be there. So it will be a part of this, which apply the friction towards the brake rotator of drums. Slowly the vehicles will slow down. And when you are slowing down the brakes or applying of the brakes with high speed or low speed, any condition, safety and stability is required. So with various safety and system, the anti-lock braking system, ABS is present modular, and traction control and electric stability control. So it will maintain the vehicle stability and prevent the skidding or loss of the control. And more electrical safety. So when you are doing such activities, or others high driving or low driving speeds, so there may chances like the electronic components can burn and such. Essentially, like we need to control that electrical system. So to provide the essentially what is needed, what voltage is needed for the light, and what voltage is needed for the switch. So that should be understood and should be maintained. And more the temperature inside or outside, it should be well maintained in the vehicle. So, and it also includes the battery and alternator, how the power is distributed from the engine. And the similarly, the same way, the battery is a one which is a main player, and it will distribute the power to the wheels. So it will be a part of a environmental control. So how whatever the gases that is releasing from the vehicle, how this is impacting to the environment. And moreover, some of the vehicle features like emission controls, such as the exhaust gas recirculation, EGR, or the selective catalytic reduction, SCR. So how it is polluting the environment. So there are some factors that should be concerned and playing a major role for taking the necessary actions for the vehicle. And monitoring and feedback, moreover, the modern vehicles equipped with the onboard computers and sensors, because to monitor various functionalities and features in the vehicle. What is the problem, what is the fuel efficiency, and how the performance is happening for the vehicle for today or tomorrow, and how it will be healthy for tomorrow. So that can be monitored with help of some advanced tech sensors and technologies that they are implementing on the vehicles. And whatever the data that we are using for the vehicles should be optimized, because adding more and more features and adding more and more components into the vehicles, it will be the weight will be more, and it will create a more load issue. So to avoid that, the number of ECUs will be splitted, and even the data the data processing is happening more. And in case like if any problem is created in the vehicle, so it will be easy identified, and it will be resolved quickly. So the data here used to optimize the vehicle operation and diagnostic problem, and provide the feedback to the warning lights and display. So overall, the vehicle operation involves the coordinated functioning of the numerous missions and electrical and electronic system to provide a safe and efficiently comfortable transportation. So that's how all engine vehicle will work. So these are the initially the power generation, power transfer, wheel movement, steering and control, and braking, safety, stability, electric system, environment control, monitoring, and the feedback. So these are the essential components are the functionalities that will be playing a major role. So where one on each should be interconnected with the system and work together to make the vehicle sustainable for the efficient operation. What are the types of engine vehicles? So generally, the engine vehicle. So the fundamental of this engine vehicles, we talks about the engine is the one which have the IC engine, or the petrol or gasoline, any type of engine will be there. And for engine, the power fuel supply, generally it will be the fuel tank. From the fuel tank, the fuel is supplied to the engine, and to initial to operate or reach to perform some actions, the battery is the one where internally it will be charged and recharged. So during the braking condition, or during the acceleration or the acceleration that you do during the braking, so that time the batteries will be recharged. These batteries will be help for some of the lightning or some of the features to be started before engine starts. So like we have a transmission and we have an axle, and we have a catalytic converter. So whatever the pollution you are getting out, so that will be converted and it will be mixed with some of elements, and it will be exhausted out with less pollution. So and we have this parallelly the braking. Braking is the one we have for it will be aligned for all the wheels. So when you apply the brake, the it should have a smooth delivering of the speed. And we have the shock absorber, because anytime the shock can be happen means due to the brake, or any firing can also happen due to the friction. And to avoid that, there will be shock absorber, so that will reduce the shock. So these are some part of the fundamental parts that will be available in the vehicles. And next will be a part of so what generally it's needed is the efficiency driving. So whenever you are driving the vehicle on the road, so the efficient driving is very important, because others conditions, the other vehicles, we don't know like how exactly the vehicle drive system will work during the traffic condition. So to know more about the comfort and safety of the cars, there are some sensors will help us to the driver to make attention during in traffic or during the long term conditions. So it may help the driver to smooth the driving and safe driving always. So what are the fundamentals of the automotive? Generally, the power and control and move the vehicle. So here, as we discussed, the engine and transmission and brake and steering and suspension. and some of the electrical components are majorly responsible for generating the power, and that will be converted into the fuel, into the energy when we are transferring the power. So that it will be generated on the wheels to make movement. So that's how the primary function of the automotive it happened. So other part will be like whenever we need to control slow or slow down the speed or increase the speed. We have acceleration parallel. We need the brake, and that should be monitored on the info driver side. We have a display, so that display we are able to see and what is the suspension we are getting and how comfortable we are able to drive. So any problem in the system, so that we are able to monitor on this display side, and mostly that will enable for drive the system very safely and securely for long run. And what are the components of an engine car? So the mainly the components of engine car, as we know, the engine is the one, the ignition key is the one where the vehicle will start. So the once the ignition you turn on, so the engine, it will be started. It will start supplying to the battery. So it means ignition is on it and it will be distributed, and the battery will be turned on. So once the battery is turned on, like from the battery, the power will be given to the spark engine. So the engine will start it, and spark plug will be getting activated and started slowly. The motor will rotate, and radiators, alternators, and there are some shock absorbers. So everything, the components will be activated one after the another. So generally, the starting of the system, like the battery. So once the battery is connected, the positive terminal, it is connected to the one engine. That is for one starter, and similarly, it's the same way we are connected to the ignition switch. So ignition switch, we have a ACC lock off on start. But generally when we start the ignition, the same signal, it will be the engine will be the battery will be activated. That it will send the signals or information to the starter. So the starter will starts. Once the starter starts, then alternator will start rotating slowly. When we give acceleration, the starting system will the system will be started. So once it started, what will happen? The next thing is the engine. So engine, we have four cycles. So this is a engine internal combustion. It happened. So this is the first in phase, like the air and fuel will be intake is will be happen. This is the piston. The piston will make a movement of up and down, and this will be the crankshaft or the crankshaft. It will make rotate. Crankshaft is the one it will be connected to the drive system, and this camshaft will be make the piston up and down. So the first phase will be the intake. Here the intake will be air and fuel air mix will be happen, and intake valve will be opened during the first cycle. Second cycle, the compression. So the compressor is the one, the piston will be in the bottom phase. During the compression, the piston moves towards the up, and it will mix both the air and fuel, and both intake and outward take will be closed, and due to the high pressure temperature, the fuel is mixed, and it will be created a high. Due to the high pressure, it will give a one power stroke. It will be a blast will happen. Due to that blast, the spark will be generated in the third cycle, and some of the dust will be formed in the power cycle. So the dust will be exhausted at fourth cycle, and the intake will be closed. So exhaust will during the intake, the exhaust will be closed, and similarly during the exhaust, the intake will be closed, and the piston moves from bottom to up and make the exhaust. So the to control the fuel intake and out fuel outtake of the exhaust and intake and outtake, so the camshafts are very majorly planed, and it will be synced to the camshaft, the bottom one. So as if you see, this is the image. So the camshaft intake and outtake. So this is helping for the fuel to take pump in and out of this. The common rod, like here we have a four cylinders. So one, two, three. So alternately it will be activated one after the other. So this camshaft, it is interconnected with the cam intake and outtake, and the crankshaft is the one which makes the to rotate the pistons. So this is about the four-stroke cycles. Like similarly, we have a two-stroke cycles, we have a three-stroke, we have a four-stroke. So depends upon the combustion on the configurations. So usually it will be available. And so whenever, yeah, the cam and crank, it will be synced together. So that time the engine will start rotating. Means the engine makes activated, and vehicle, that power will be distributed towards the wheel for the rotation, for the rotation of the wheels. So next will be the engine components. As we discovered, engine components like internal combustion engine, ICE, the most power. Traditional cars, we have this petrol and diesel engines, and next will be the electric motor. Mostly it is a combination of both batteries and the ICs. So it founded in hybrid and electric vehicle, where it will convert electrical energy into the mechanical power. And engine block, so mostly it will be the housed on the cylinder where the fuel combustion occurs. And piston, it moves and up and downs with the cylinder, transforms to the crankshaft. Crankshaft is nothing but it will convert the linear motion of piston into rotation motion. As this is a linear motion, it will come whenever it is rotating, it will create the rotation motion. And timing and belt, as the cam and crank should be synced together, then only the vehicle will be started. And valve train, so whatever the intake and exhaust, you should be synced together, and the gases will be exhausted. So these are some common names. Cam will be the initial phase, it will take control of the air fuel mixture, and exhaust, we have the valve. Similarly, we have the crankshaft, and for crankshaft and the piston, we are connected with the connected rods. And we have some space. This is the combustion chamber, we usually say, where the intake and exhaust of the operation plays major role in the combustion chamber. And next will be part of the like some of the oil